Hello everyone. This presentation is hopefully going to provide a summary of an exploration for you related to the evolution of natural language-based societies of mind and their potential extensions to derive real-world societal impact from AI collaboration to global problem solving. Let me begin with the outline. Marvin Minsky, in The Society of Mind, one of his major works, explored the idea that intelligence emerges from a collection of simple interacting agents rather than a singular unified process. This captures the essence of his Society of Mind theory, which has computational implications, suggesting that AI and cognition can be understood as an assembly of modular interacting components. Later, Jürgen Schmidt-Huber, in his work on artificial general intelligence and meta-learning, has explored the concept of learning the thing, suggesting a framework of interacting agents, preferably in natural language, as the medium of communication. This aligns with his broader research on reinforcement learning, recurrent neural networks, and self-referential systems that enhance their own learning processes. In our presentation, we'll explore Minsky's Society of Mind, which suggests intelligence emerges from simple agents working together. Intelligence originates from microagents collaborating to form cognitive abilities, a concept expanded by Schmidt-Huber's later, where learning is a recursive process of optimizing decisions over time. Natural language society of minds, including LLMs and VLMs, facilitate AI collaboration through multimodal reasoning. Experiments show AI cooperation enhances efficiency and decision-making. Future directions include scaling this type of systems, optimizing AI negotiation through economics of mind, and exploring AI societies with distinct characteristics. As AI advances, Minsky's vision of collaborative intelligence seems to continue to shape our future. Let us discuss this recent work first, Natural Language-Based Societies of Mind, or NLSoMs, which I find quite relevant, a novel framework inspired by two groundbreaking ideas. First, Marvin Minsky's Society of Mind, which suggests that intelligence emerges from specialized modules working together. Second, Jürgen Schmidt-Huber's Learning to Think, where natural neural networks learn by interviewing each other to extract knowledge. Natural language-based society of minds take these ideas further by creating societies of large multimodal neural networks like LLMs and VLMs that communicate through natural language. These agents collaborate in what we call mindstorms, or what this study calls mindstorms, iterative multimodal reasoning sessions where they debate, refine, and vote on solutions. Why is the natural language so important in this context? Because it's the modular aspects of human mind. Agents can be added or replaced easily, and it's explainable. Humans can audit the reasoning process carefully, and it's human-aligned. Language inherently encodes the human logic, making the AI systems more intuitive and trustworthy. Here are the key experiments and findings of the study, and let's dive into these experiments in deeper. In visual question and answer, we found that a monarchical NLSoM, where a central leader makes decisions, outperformed a democratic one, achieving 67.42% accuracy. Why is that? It's most likely because vision models, VLMs, had weak language skills, and democracy diluted the expert opinions. And the text-to-image synthesis, on the other hand, they build an artistic critic NLSoM with 129 agents, and this system generated richer prompts than single agents by mimicking human creative workflows with specialized roles like artists and critics. For egocentric retrieval, democratic NLSoMs excelled when agents had complementary partial observations. Voting pooled diverse perspectives, reducing individual blind spots. Finally, in the embodied AI, agents collaboratively navigated environments, outperforming random exploration. A captain, LLM, synthesized summaries from an observer, which is a VLM, and a first mate, which is also made of a LLM, demonstrating the power of the teamwork. Scaling these trends showed that performance improved with more agents and longer Mindstorm sessions, suggesting that the NLSoMs are highly scalable. Let us discuss how natural language-based society of minds can scale to thousands or even millions of agents, including humans. And to achieve this, we need efficient communication protocols, hierarchical structures, and mechanisms to manage large-scale interactions. Some of the key fundamental questions arise in this context. First and foremost, how can we design communication protocols that minimize redundancy and maximize efficiency? The other relevant question, what are the scalability limits of the NLSoMs, and how can we overcome them? Finally, we also have to discuss how can we ensure that adding new agents, whether human or AI, does not degrade the overall performance. If successful, scaling NLSoMs could create highly collaborative AI systems capable of solving complex real-world problems across fields like healthcare, climate modeling, and large-scale decision-making. And this research has the potential to revolutionize how AI collaborates and evolves. Another potential application area is social structures and governance in NLSoMs context. You might explore how different governance models, such as monarchical, democratic, or federated structures, affect the decision-making process, efficiency, and fairness in the same context. Studying these structures would help us understand which models work best under different conditions. Key questions to consider include when democratic NLSoMs outperform monarchical ones and vice versa. How we can design NLSoMs that resist manipulation or bias, especially when humans are involved, and what role humans should play in governance to ensure AI systems align with human values. The potential impact of this research is quite significant. By identifying optimal social structures, we can create AI systems that are more robust, fair, and aligned with societal goals, ultimately ensuring responsible AI development. Yet another direction is about the economics. In this approach, agents can exchange services or resources like information or computational power using a shared credit or currency system. By integrating reinforcement learning techniques, we can aim to optimize resource allocation and reward distribution, making the system more dynamic and self-organizing. We may be exploring, three fundamental questions within this same context. First, how can we design a credit or currency system that truly incentivizes cooperation and innovation within NLSoMs? Second, how can the reinforcement learning be utilized to optimize the behavior of individual agents in this economic setting? And third, what are the ethical implications of embedding economic systems into AI societies? And how can we prevent exploitation or inequality? The potential impact is profound. Economics of minds could enable self-sustaining AI systems capable of autonomously allocating resources, solving complex problems, and even trading with human economies. This could have far-reaching implications for industries such as finance, logistics, and resource management. Let us explore another crucial research direction: investigating the ethical and safety implications of natural language-based society of minds, particularly in scenarios where AI agents interact with humans or have significant real-world impact. Our focus, this research or this direction's focus could be on developing frameworks that ensure transparency, accountability, and fairness in the same system. We are asking key questions in this genre of research, such as how can we ensure that NLSoMs are transparent and explainable, especially when making high-stakes decisions? What safeguards can be implemented to prevent these systems from being used maliciously, for example, in spreading misinformation or manipulating markets? And how can we ensure that NLSoMs respect human rights and ethical principles, even in complex multi-agent environments? Addressing these concerns is essential by creating AI systems that are not only highly capable, but also trustworthy and aligned with human values. We can help mitigate risks in sensitive areas like healthcare, law enforcement, and governance. Natural language-based society of minds can also be integrated with societies formed by humans. The issues are related to integrating neural level self-organizing models, or NLSoMs, broadly, into human societies as collaborators, advisors, or even decision makers. Our focus is on understanding how humans and AI agents can communicate and collaborate effectively within a shared society. We're addressing several key questions within this research. First, how can we design interfaces that allow humans to interact seamlessly with NLSoMs? Second, what are the psychological and social impacts of integrating these systems into our communities? And third, how can we ensure that NLSoMs enhance human capabilities without displacing human roles or worsening the inequality problem? The potential impact of this work is, again, profound. Successfully integrating NLSoMs could lead to unprecedented levels of human-AI collaboration, enabling us to tackle some of the world's most pressing challenges such as climate change, poverty, and disease. How about the research domain extensions, being NLSoMs to include embodied agents such as robots and multimodal capabilities like vision, audio, and tactile sensing, all managed together? The goal here is to develop agents that can perceive and interact with the physical world, as well as communicate effectively with other agents and humans. In this branch of research, we are trying to focus on several key questions again. First, how can we design NLSoMs that effectively integrate multimodal data, visual, auditory, and textual, to solve complex tasks? By the way, these modalities could change based on the application. Second, what challenges arise when integrating embodied agents into NLSoMs, and how can we overcome these obstacles? And third, how can NLSoMs enhance human-robot collaboration in real-world environments? The potential impact of this research is, again, significant because multimodal and embodied NLSoMs could revolutionize fields like robotics, autonomous vehicles, and smart cities, enabling these AI systems to interact with the physical world in more sophisticated and human-like ways. Another important research direction focuses on investigating how NLSoMs can learn and adapt over time through mechanisms such as lifelong learning, meta-learning, and transfer learning, with the aim of developing agents that continuously improve their performance and seamlessly adapt to new tasks and environments. Here, in this branch of research, we are planning to explore key questions, including how to design NLSoMs that effectively leverage past experiences to solve novel problems. In other words, the generalization problem. What mechanisms can be employed to ensure these systems remain robust and reliable over long periods, and how they can dynamically adjust to changing environments and unexpected challenges. The potential impact of this work, again, going to be very significant. A long-term learning and adaptation could result in AI systems that are more flexible, resilient, and capable of handling complex, dynamic settings, with far-reaching applications in areas like disaster response, space exploration, and personalized education. And yet another different research branch could be a direction that explores how NLSoMs can operate effectively across different domains, such as healthcare, finance, and education, while also adapting to diverse cultural norms, languages, and value systems. Key questions here include how to design NLSoMs that function seamlessly in varied cultural and linguistic contexts, what challenges arise when transforming or transferring knowledge or transforming knowledge and skills between different domains, and how these systems can help bridge gaps between cultures and communities. Addressing these challenges could enable AI systems that facilitate global collaboration and knowledge sharing, ultimately leading to more inclusive and equitable AI solutions that would benefit people from all backgrounds. And We are also, while we're discussing all these application areas, we're also interested in theoretical foundations of NLSoMs. So this research direction would focus on developing this framework, this theoretical framework, to better understand the behavioral dynamics and limitations of NLSoMs by exploring their mathematical and computational foundations and their relationship to AI and cognitive science. Key questions include identifying the fundamental principles that govern NLSoM behavior, formalizing concepts like mindstorms, as we discussed earlier, or any other emerging phenomena, and determining the computational limits of these systems while exploring ways to push those boundaries. Gaining deeper theoretical insights into NLSoMs could lead to more efficient and effective AI systems, while also advancing our understanding of intelligence itself, pretty like in its definition, or redefine it from ground up, both artificial and human, potentially shaping the future of AI development and cognitive modeling. And finally, I'd like to talk about this research direction where we focus on, or plan to focus on, applying NLSoMs to real-world challenges in fields like healthcare, climate science, education, disaster response, by developing specialized models tailored to specific domains and specific requirements and needs. Key questions here include how NLSoMs can accelerate scientific discovery and innovation, what obstacles arise when developing or deploying these systems in real-world environments, and how they can be leveraged to tackle global challenges such as climate change or pandemics or inequality. Successfully integrating NLSoMs into these areas could lead to groundbreaking advances in science and technology and society as a whole, transforming how we approach complex problems and driving meaningful progress on a global scale. The applications also can be extensive, although we have explored a few with this presentation. So our exploration of natural language-based society of minds should span fundamental theory, ethical considerations, cross-domain adaptability, real-world applications, and future advancements in AI and AI-human collaboration. By addressing key challenges such as transparency, adaptability, and multimodal integration, I believe we can unlock the potential of these systems to drive scientific discovery, enhance decision-making, and tackle some of the world's most pressing issues. As we continue this line of research, our goal would be to develop AI that's not only powerful and efficient, but also ethical, inclusive, and aligned with the human values. Thank you for your time, and I look forward to your thoughts and questions.